Okay, we can continue with part two of our discussion of omitted variable bias. So the context is we're imagining a single variable regression model where earnings depends on education. Our assumption is that beta 1 is unbiased if the expected value of the error term, which includes all other factors, that is, other variables that are affecting the outcome, if the expected value of the error terms conditional on the level of education is equal to zero, and that will not be the case if there are confounders, if there are other factors correlated with education and also causing earnings. In that case, then beta 1 hat will not be unbiased, it will be biased. And then we want to work through the direction of the bias. So we have our two-part test for the direction of the bias to think about this emitted variable. Is this emitted variable correlated with the explanatory variable? Is there an emitted variable correlated with education? And does this emitted variable independently cause the outcome, in this case, earnings? And we can think of a z variable then, this emitted variable or this confounder. We can work through what the direction of the bias is. There are 8 cases. I've already done one of the cases in part one. Here's case number two that we'll think about. So in this case, we'll think of the emitted variable being maybe, since most of the viewers of this are probably university students who recently finished high school, so there's a lot of kids who smoke a lot of pot, weed, or whatever you want to call it, or they take a lot of gummies and they're walking around high all the time. So let's imagine that that's the confounder. So the correlation between being high all the time, smoking a lot of weed, and education is not equal to zero. We'll imagine it's a negative correlation. That is, people who are smoking a lot of pot, especially in high school, they're probably not doing very well in high school. Maybe they barely graduate from high school. They're not going to go on to college, or very lower likelihood going on to college. And sure, you may think you're that exceptional one. Oh, I get high all the time and I'm doing great at university. But most people on average, if they're getting high all the time, probably not succeeding in academics and hence are having less education attainment or less quality education attainment than other people. So the correlation we might imagine is negative. It's an empirical thing, we're just having a consensus here about what the likely correlation is. And we might also think that smoking a lot of pot, smoking a lot of weed, it has an effect on your earnings, and it's probably a negative effect. A negative effect. That is, the more pot you smoke when you're out working, the more your manager knows you're high all the time, not being very efficient, not being very effective, and so you'll earn lower. So our confounder meets the two-part test, and so beta 1 hat would be biased. Now we want to ask what's the direction of the bias. So we imagine a true relationship, we imagine the errors relative to the true relationship, and then we see what the estimated line will look like. So the first thing we do is we have our scatter diagram of education and earnings, and we imagine a true relationship, right? Our true relationship is this positive relationship. So we imagine that that there is some true relationship or population relationship out there. And then we ask what the pattern of errors would be that would show up in our observations in our sample that we draw from the population. And this is what the pattern of errors would look like. For people with low education levels, they're disproportionately the people who smoke a lot of pot. So disproportionately, their earnings are even lower than they would be otherwise, right? Because not only do they have low education, but they're also smoking a lot of pot. So they're having even lower earnings than they would be otherwise. On the other hand, the people with high education are the people who are not smoking very much pot. They're sober all the time when they work, so they're more effective than other people at work, so they have even higher earnings than just their education would allow. Back in my day, there was something called the, straight edge punk rock movement. Like we're punk rockers, but we don't get drink alcohol or get high. So those people may be more productive on average. So that's our pattern of earnings. Once we have that pattern of earnings in our sample, right, with negative errors for the people with low education and positive errors for people with high education. Now, when we try and fit our best slope line through the dots, right, we're going to get something like this. The estimated slope using the sample observations is going to be steeper than the true slope. So that is, we're going to have, let me make this so that it doesn't disappear. We're going to have beta 1 hat, our estimated slope, is on average the expected value. We could think, because this is just one sample, we could have many samples, but on average it's going to be steeper than beta 1 true, right? So on average it's going to, this is the language I like to use, it's going to look like education has a big effect on earnings, but really that's not the case. People with low education, it isn't that they're earning less because of their low education. It's that people with low education are really earning less because they're smoking a lot of pot, and that's why they're earning less, right? It's not so much the low education. So our estimated slope would be biased, and we can see the direction of the bias. And of course, we could correct for this bias. All we have to do is include some measure of how much pot you smoke in our regression, and then we control for that. And our estimated coefficient would then be unbiased because now we're including this omitted variable in our regression analysis. So that's case two of how omitted variable bias works, and I'll have some more cases forthcoming.